Okay, so as we move forward and add or subtract our fractions and identify any x values for which our expression is undefined, well, just like yesterday when we were multiplying or dividing, the first thing we are going to want to do is factor our expression. So 1 over 3x squared cannot be factored or simplified in any way, but our second fraction, we've got 9x squared minus 12x in our denominator. We have a GCF of 3x. So then that second fraction alone becomes x over 3x times 3x minus 4. So before we start thinking about what our common denominator might be, let's see if we can't reduce first. Maybe it will help us, maybe it won't. Either way, it's not going to hurt. We have an x over an x, so we can cancel those. So as I rewrite this, I have 1 over 3x squared plus 1, if everything else is gone in our numerator, over 3 times 3x minus 4. So now, as we are working through what we need our least common denominator to be, let's think about what we've got for our factors. So up here, our least common denominator we took by taking 3 times 2. But over here in example B, we had some common factors, right? The 4 was common in both, so we didn't need it twice. So this time around, our factors of our first denominator are 3, x and x, or x squared. And then in our second denominator, we've got 3 and 3x minus 4. So we want the least common multiple of all of those. Well, I know I'm going to need a 3 in my least common denominator. I'm going to need an x squared, since I've got an x squared right there. And then in our second fraction, we've got that 3 again. Well, I already accounted for it, so I don't need to worry. And then I am missing this 3x minus 4. So altogether, our LCD needs to be 3x squared times 3x minus 4. So now what we do is we multiply both fractions by whatever piece is missing. So in our first fraction, 1 over 3x squared, well, we've got the 3x squared piece. All we're missing is the 3x minus 4 factor. So we'll take both of them, the numerator and the denominator, and multiply by 3x minus 4. In our second fraction, we will have, let's see if I've got 3 and the 3x minus 4. The 3 and the 3x minus 4, we're only missing the x squared. So in our second fraction, I multiply top and bottom by x squared. So our first fraction becomes, when I take 3x minus 4 in my numerator and multiply by 1, I get 3x minus 4 over my LCD, 3x squared times 3x minus 4. And then plus 1 times x squared over my LCD, 3x squared times 3x minus 4. Once you have a common denominator, you can just add right across the top and keep your least common denominator as is. So 3x squared times 3x minus 4. And then in our numerator, we've got x squared plus a 3x plus a negative 4. So that's how we will write it. Now, there's no rule that says you can't call it 3x minus 4 plus x squared, but putting it in standard form is never a bad idea. Now, again, just like we did yesterday, if our first step was to factor, our last step can also be to factor. We might have a chance to get something to cancel, and we won't recognize that unless we factor at the end as well. So our denominator is still as factored out as it can be. That's fine. So 3x squared times 3x minus 4. In our numerator, I'm looking for two numbers that multiply to give me 4, subtract to give me 3. That'll be 4 and 1. My signs are different. My bigger number is positive x plus 4, x minus 1. Well, I don't have any factors that cancel, but that's honestly okay because I just have to double check anyway. Now, lastly, we need to identify x values for which our expression is undefined, aka that's basically our domain. So again, we think back to our very beginning and think about all the things we couldn't plug in. Well, in our first denominator, I couldn't plug in x equals 0. Because if I did, I would have 1 over 3 times 0, which is 0. And then in our second fraction, after we factored, we had 3x times 3x minus 4. So again, x can't be 0. We don't need to restate that. But x, based on my 3x minus 4, can also not be positive 4/3. So those two values would cause my function, or my expression, to be undefined. Alrighty, in example B, again, let's start by factoring. So I've got x over x plus 3, those are fine, those aren't going anywhere. 2x plus 6, I can at least take out my GCF of 2. So 2 times x plus 3, and in my denominator, I have x plus 3, x plus 3. Now, it helped us in this case to factor first because now we can get that x plus 3 over x plus 3 to cancel. So now all we're doing is taking x over x plus 3 plus 2 over x plus 3, which is great because now we already have our common denominator. I just add my fractions like normal. I have x plus 2 over x plus 3. Ta-da! Again, we have to identify values for x for which our function or our expression is undefined. So go back to your very beginning. Oh, x cannot be positive 3 based on that guy right there. Or excuse me, negative 3. And then these guys were both x plus 3, so 3 times over, x cannot be negative 3. In example C, now we are subtracting our fractions, so we really have to be careful as we watch what happens when we distribute that minus sign. So we still start by factoring. So I've got, for my numerator on top, 2 times x squared minus 15, which is not factorable. If I had dots like x squared minus 9 or x squared minus 16, I'd be okay. I don't. But notice in my denominator on the left, I do x plus 3x minus 3. And then x plus 5 can't be factored, x plus 3 cannot be factored. However, that helped us because our least common denominator, well, okay, this denominator is x plus 3, x minus 3, and this one's already x plus 3, so the only thing we'd be missing would be the x minus 3. So our LCD is going to be that x plus 3, x minus 3, or if you FOIL it out, x squared minus 9. Doesn't matter either way. So I rewrite everything how I can. So 2 times x squared minus 15 over, I'm just going to call it x squared minus 9, feeling lazy, minus x plus 5 times x minus 3 all over x squared minus 9, which again we know to be x plus 3, x minus 3. Well, in our numerator, we are able to combine all of these like terms once I FOIL out these guys. And again, I'm going to have to multiply that 2 back through since I'm subtracting, since my goal is to combine all of my like terms. So yeah, I factored out that 2, and now I'm just FOILing it back in or distributing it back in, but it didn't hurt us because maybe sometimes something will cancel. So my denominator is going to stay x squared minus 9, or x plus 3, x minus 3. My numerator, I'm going to have 2x squared minus 30 minus x squared plus 2x minus 15, if we FOIL that out. Notice I put it in parentheses. We are subtracting that whole polynomial, so we have to distribute the minus sign. So I've got minus x squared minus 2x plus 15. And then let's go ahead and factor it out. X plus 3, x minus 3. And then 2x squared minus x squared, I have 1x squared. And then minus 2x has nothing to combine with it. Minus 30 plus 15, that is a minus 15. Now that's good news for us because, again, our last step should always be to factor. Our numerator is actually factorable. We can factor that guy into x plus 3, x minus 5, which is really, really good news because since our denominator is x plus 3, x minus 3, we notice that our x plus 3's cancel. So our final answer is x minus 5 over x minus 3. Again, what values would cause our expression to become undefined? We'll think back to our values from the very beginning. So if I set my LCD of x plus 3, x minus 3 equal to 0, x cannot be positive or negative 3. Alrighty, in example D, let's go ahead and start by factoring. So x plus 1, fine, can't be factored. My denominator is x plus 2, x plus 2. And then my denominator on the right is x plus 2x minus 2. So if we look at all of our factors, we've got x plus 2 common between the two of them. And then we've got an additional x plus 2. We have to account for that. Plus we've got this x minus 2 hanging out over here. So my LCD is going to be both x plus 2's, which I can call x plus 2 squared, and the x minus 2. So I need to figure out what I need to multiply each fraction by. So my first fraction, I have the x plus 2 squared, but I don't have the x minus 2. So I need to take this guy times x minus 2, and then that's what I'm multiplying by on the bottom as well. Our second fraction, I am missing the second x plus 2. So that's what I'll multiply by on top and bottom. So I'm going to go ahead and write this with our common denominator already because it's a lot to write out. So I have x plus 2, and x minus 2. And then on top I have, okay, x plus 1 times x minus 2. I can FOIL that right now. I have x squared minus 2x plus x minus 2. And then we're going to be subtracting 6x plus 12. Again, we need to remember to distribute that minus sign. So it'll be minus 6x minus 12. And then we'll be able to combine our like terms. So we'll have x squared, nothing to combine with that, minus x minus 6x minus 7x, minus 2 minus 12 minus 14, all over our LCD. X, whoopsies, plus 2 squared times x minus 2. Our numerator, we'd look to see if we can factor it. I don't think we'll be able to, so we will call it good. What values of x would cause our expression to be undefined? We go back to the very beginning. X cannot be plus or minus 2.